Yeah, so as I was saying, we are going to continue our adventures of learning about solutions, right? And so today's activity is going to be more about talking to you, kind of going a little backwards. Remember how we've already done things that use solutions and let solutions like help us to like make stuff? Today I'm going to take it back to what substances will actually make a solution with water. Okay? What are some of the things we can put in water and get a solution back? Okay? So that's what we're doing on today. Welcome, welcome, welcome to our fun time that we have every Saturday. For those of you who do not know, frankly now you know. We're here every Saturday. Last week's activity was a little closer to my like 5th graders and stuff. This week's activity is great for everybody. There's a way to make this work for all age groups. So I encourage you, and like you can pick different materials from your home. So I really encourage you to try it out and work it out. All right, so let's make sure that we're live and sharing on all of our platforms and conduits, folks. Thank you again for joining me. And as I said before, I miss Steph, just in case you didn't know that. In case you didn't know, for all my newbies, hi, I miss Steph. And we do this every Saturday. Boom. Every Saturday-ish, almost every Saturday, like probably a good 40-something Saturdays out of the year. Okay, this is like our thing. And if we get enough support to do it, I'll just keep doing it, even after the thing that we won't name today, just because I don't feel like talking about it today. Even after that whole situation has passed, if we get enough interest, we'll continue it. Okay, probably at another time of the day, because I would normally physically be at a location, right, teaching in person and letting kids run around. Nehemiah can tell you about it. Alrighty then, so let's go ahead and roll. Once again, Facebook, please tell me if you cannot hear me. I'm going to need you to say a little something. Or like if things get if it starts to sound strange or something, let me know. Okay. We're shared on various platforms and stuff, and now I'm going to break things out. As I said, today's activity can be done, not only can it be done with various age groups, it can be done with various materials. You don't have to use the stuff that I'm using to do this. I really encourage you to try actually other things than what I'm using. Okay? So main thing that you definitely need some spoons. You need a different spoon per substance that you're going to test, because we're testing things, okay, for their solubility, their ability to dissolve and mix and make a solution in water, or rather with water. Okay, so you want a different spoon for all of your substances. Okay, capiche? And of course you need water. Hello. Yeah, because we're testing stuff in water, so you're going to need some water. And then of course you need a cup for each substance. So we should get to labeling, right? We need to get to labeling, because you're going to need a cup for each substance. Okay? I am going to do a cup that's not going to have anything in it. It'll just be the water, so we can compare. Okay? So once again, thank you for joining me. Miss Steph here, live for Saturday Science with Miss Steph, or Science with Miss Steph is kind of what we've just shortened it to that. Okay, I had a class earlier, a private class earlier, a smaller class. By the way, that's a possibility. So send me an email if you want to do that, and have like a one of your small groups do an activity with me. We can do a little private Zoom class. But that being said, I had a class which was great. It was fun. If any of y'all are watching, thank you. You guys did a great job. And one of the kids, he's so cute, he asked me, so are you in a real laboratory or are you at home? The answer to that question is yes, right? I'm at home, okay? And I'm not in a lab that has been built out, but is this my lab? Yes, it is. That's how I feel about my home, especially this little part of my home, right? Y'all know, we've been spending months together, right? Okay? So, that being said, let's roll. Okay. So I'm all set up. You know how I am. So I'm being silly and all that type of stuff because this was recorded live like it is every Saturday and whatnot and what have you. But I'm tilting my camera and whatnot so that folks who are watching live can see. Basically, it's time to get to the nitty-gritty. We're not completely ready to do the experiment portion, but we are in the final setup step. So now that I've got all of my cups labeled and I know what I'm going to test, I'm going to start to put the correct amounts of substances into each cup. All right? After I do that, then you'll see me mix them together and we'll do a final analysis and whatnot and what have you. But keep watching so you can find out which substances are actually soluble in water and will form a solution with water. This is what I thought would be interesting, and it's a vast array, right? It's a big variety. Okay, so now I have all of my substances inside of their test vessels, right? I'm using all of those terms because those are the terms that we would use in the lab, right? Okay, remember, yes, like I told my student earlier, yes, I'm at home. And I'm in my lab. This is my homemade lab, okay? So, as far as the amount of liquid, let's go ahead and measure. Now, is this a standard measurement device? No. However, we can standardize it by going ahead and drawing a line. Draw a line and use this like it's our measuring cup. Let's turn this in your direction. See? Would I measure like this normally? Absolutely not. Okay? But I'm doing it this way so that you can see what I've got going on. Okay? So a solution and a mixture are similar, right? So technically a solution is a special kind of mixture. I'll repeat, a solution is a special kind of mixture. All right, so let's see if this is just a mixture or if it's our special kind of mixture that we would call a solution. So pepper. What happens with pepper and water? Does it look like the pepper is disappearing? Or does it look like the pepper is just in there? Does it even look like the pepper is mixing in? Is the pepper even combining with this? Or is it just kind of there? The water and the pepper are still separate. Alright, so that's my first test substance. Alright, so next thing. First of all, the situation with this one, with the food coloring, right? Now the food coloring is most likely made out of a powder plus some liquid, okay? However, when we got it, the food coloring was not a powder. So technically we made a dilution. We made a diluted form. We took an already made solution and then combined it, okay? An already made like liquid and combined it, right? So that's a dilution and not a solution, all right? Water, remember water is we're just comparing. We're using it as something to compare the rest of the samples to. Boom. And then now let's mix up. Let's stir. Stirring our salt. Stir, 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 stir. Okay. Salt. Anybody who's ever made soup or salt water to gargle with, right? You know that salt, okay, should dissolve, right? Now, does it dissolve easily or what we call readily? Not too tough. It takes a little while. It takes some agitation. It takes some mixing, but it does eventually, see? It eventually dissolves. It eventually mixes in to the point to where it looks like it has disappeared and you get a slightly cloudy situation. Okay? So now let's see if the same situation happens with our baking soda, basically our other type of salt, our bicarbonate, right? Our sodium bicarbonate. Sodium bicarbonate is simply the scientific term for baking soda. That is actually describing, it's a more descriptive way of communicating what's inside of the baking soda. That is really giving you a clear impression of what's inside of the baking soda. Sodium ions and bicarbonate ions. Sodium, carbon, and oxygen, actually. Alright, so there it is. That's what it looks like right now. If I let it sit for a little bit longer, it will dissolve some more. And it's got kind of this white on top. Put this here. See? Now, before I even start stirring the jello, right? Should the jello make a solution or a mixture, right? And when I stir it, do you think it will be thicker than my other mixtures, right? Think about it. Think about what's inside of pudding, okay? And now towards the bottom, the sugar that's in our jello pudding mix kind of sank to the bottom a little bit. Okay? And then we have the gelatin and the other things that are inside of jello pudding mix. Okay? So we have all of our samples we've taken, okay? Or rather we've made all of our samples, right? All of our test samples. And so now let's do the analysis portion. The analysis portion of the activity, right? Because we're scientists. So we do things and then we actually come up with an analysis. We take the information and translate it into a conclusion, right? Basically, what did we learn? Okay? So let's go back over everything and then we'll be done for today. We'll sign out. Okay, and next week we'll talk a bit about how we can make our own DIY crystal solution. Remember, we started this series at the very beginning of January with me making some crystals from a kit. Next week, I'll talk to you about making crystals from a DIY solution, from a solution that I will show you how to make. All right, so, and some of what we've done today will help make that activity make sense for you. All right, so here, so the pepper, a lot of the pepper is floating, okay, right? So you can see the pepper does not dissolve. No, okay? Pepper does not form a solution with water. Okay. This one, remember the food coloring it gets diluted. Now I know it's quite, very dark, but that's because we put in a lot of that green food color, okay? But, and also food coloring is meant for that, right? Isn't food coloring meant to add quite a bit of pigment with just a little bit of the substance, okay? So that's just a dilution, all right? Of course, water is just our middle sample. I have that sample in the middle just to give you a reference. This is what plain old water looks like. If we were to compare each thing to plain old water to help us determine how soluble our substances are, that would help us out. So let's start to compare, right? Let's hold up, this is the water, and this is the water with salt in it. Water with salt in it. So you can compare the two. You notice that the salt water is a bit cloudy, okay? But if you didn't know that it was salt, you'd say salt in it. You could say that something was in there, but you knew it was a solution. Same here with my baking soda. It's a bit cloudy, but the majority of the baking soda has dissolved, right? You see how it's starting to clear up a bit? Not just a bit, actually quite a lot, right? Depending on the angle that you're looking at it at, like you can tell that it's clearing up a bit. And then look at this. So not only, I want to kind of tell you something that is hard for you to observe on camera, right? Not only is this cloudy and clearly not clearing up at all, it's not becoming translucent, I'm not going to be able to see through it, but it's also feels significantly heavier than my water sample, okay? So this is my plain water, and this is my water plus Jello pudding mix. So it's always important in science to have something to compare to. That's why we do a control sample. Yeah? Something to compare to. So out of 1, 2, 3, 4, 5 test substances, my analysis is that there are only 2 of my test substances that actually make a solution in water, that will combine in water and essentially disappear in the water. It dissolves well. And FYI, this water is kind of on the cold side. But next week, we'll be using some warm water. Think about what that might do to help or hinder our solid from dissolving. What would that do? Is that helpful, or would that hinder our solid from dissolving? Okay? Does it make it easier for a substance to dissolve if it's in hot water? All right, folks, I think we've learned a lot today. absorb a lot of information. So remember, you can contact me and ask me questions. Last week we had someone on here that helped me choose what color I should use. Actually, they chose green for last week's activity. And next week we will use some food coloring, because you know how I feel, color makes life better. So remember to tune in so that you can help me choose what color to make my crystal forming solution. Okay? If you have any questions, like I said, put them in the chat, and you can always send me an email. Thank you so much for joining me for Saturday Science with Miss Steph. Everyone have a wonderful and awesome, safe Saturday.